Hello everyone. Today I'm going to discuss about calorimetry. It's one among the photometric techniques, and photometric techniques means it is based on intensity of beam of monochromatic light. So in the case of calorimetry, it is based on density of monochromatic light in the visible spectrum. It measures concentration of sample or analyte using the absorbance or transmittance of that particular monochromatic light. So it can be defined as a technique used to determine the concentration of colored compounds, that is analytes, in the sample solution at visible spectrum of light 400 to 800 nanometer. Accurately say it's in the range 320 nanometer to 700 nanometer. Colorimetry. It is based on the principle that a colored solution having particular analyte have the property of absorbing certain wavelength of light when a monochromatic light is passed through them. So the analyte present in that particular solution or the particular amount or concentration of substance in that particular solution absorb the light that enter through monochromatic light. At that amount of light absorbed or transmitted by that particular colored solution is in accordance with two laws, Beer's law and Lambert's law. So that's the principle of behind calorimeter. So first one is Beer's law. So when a monochromatic light passes, it enter into the medium or the solution, a particular amount of light is absorbed and balance amount is transmitted, and this is connected with the concentration of analyte in this solution and the path through which the light is traveled. That is mainly taking consideration in Beer's law and Lambert's law. So the first one is Beer's law. Beer's law states that when a chromatic light passes through a colored solution, amount of light transmitted decreases exponentially with increase in concentration of colored substance. That is, the amount of light absorbed by a colored solution is directly proportional to the concentration of substance in the colored solution. So, this particular light source get into this solution and transmitted, the intensity is decreased and it is proportional to the concentration of substance present in this particular solution. That is Beer's law. Next is Lambert's law. Lambert's law states that the amount of light transmitted decreases exponentially with increase in path length or diameter of the cuvette or thickness of colored solution through which light passes. That is, the amount of light absorbed by a colored solution depends on path length of the cuvette or thickness or depth of the color solution. So this transmittance is decreased transmittance is because of absorbance in this particular solution is dependent upon the length, path length and density of this particular solution. And the combination of Beer's and Lambert's law is that the absorbance is directly proportional to the concentration of solution. So the absorbance depends on molar absorption coefficient, that is A is equal to absorbance is equal to molar absorption coefficient, that is epsilon, then molar concentration of the analyte in that particular sample, the concentration of analyte in this particular sample, and L is the path length. So the optical path length of the light, also it depends upon optical path length of the light. So that is Beer-Lambert's law. Based on Beer-Lambert's law, absorbance is equal to the molar absorption coefficient, molar concentration of analyte, and the optical path of the length. And based on this particular principle, calorimeter is worked. So next, considering an estimation. Considering an estimation of a colored solution, it requires three necessary solutions. The first one is blank. The second set is set of standards, and the third one is test, where the unknown, so concentration of unknown want to be identified. The first one is blank. It is used to eliminate the effect of light absorption by the reagents used. Mostly there are two blanks, water blank as well as a reagent blank, and this particular value of blank is subtracted from the test value. Then only correct amount of analyte or unknown concentration can be measured. Next one is the standard solution, a set of standards. They are solutions containing a precisely known concentration of substance or analyte. Normally, they are placed in an increasing concentration. For example, if we needed to analyze a test in between the concentration 5 microgram to 10 microgram, we may use a standard having concentration from 2 microgram to 15 microgram. So the standard set consists of from 2 microgram to 15 micrograms, and the unknown concentration is in between 5 to 10 microgram. So both of the OD, optical density, and the concentration of standards are known. So from this known value, the unknown test value, test concentration can be calculated through formulas as well as through graphical methods. From this particular formula, that is calculation OD of the test, optical density of the test, divided by optical density of that particular standard into concentration of standard, give the correct concentration of the test sample. Next is the test. Test solution is made by treating a specific volume of test sample with a particular reagent as per the procedure. There are different chemicals are used for that, or different procedures are there. Next, the calorimetry mainly works better in the range of 380 to 700 nanometer wavelength, that is in the visible spectrum. So visible spectrum is in this 380 or 220 nanometer to 700 nanometer. So calorimeter work in this particular spectrum. Now a picture of a calorimeter. Sorry. Next, the components of a calorimeter. Consider the basic components of a calorimeter. The instruments have a light source, usually a tungsten lamp for the wavelength in the visible range 320 to 700 nanometer. Tungsten will be sealed in a glass envelope tank filled with inert gases, and if sufficient intensity of light is not produced or obtained, instead of tungsten lamp, there are carbon arc lamps used in certain calorimeters as a source of light. Next, there is a monochromator or a filter. This filter selecting a sufficiently narrow band, and filter will absorb the light of unwanted wavelength and allow only monochromatic light to pass through the solution. For example, if green filter is used, then it absorbs all colors except green light, which is allowed to pass through. So through that only a green light is passed. In this case, a yellow filter is there. So only yellow light is allowed to pass through this solution. Next is if considering this particular monochromator consists of an entrance slit will be there, then there is absorption or interference filter will be there, then a prism or diffracting grating for wavelength selection. Particular wavelength can be selected. If you want a green filter, then it's chosen here. Yellow filter, then yellow filter is chosen here. So according to the wavelength that you wanted, selection is here, and then there will be an existing exit slit through which the wavelength this particular light is passed through the sample solution. Next, here the sample is holding in a sample holder or a cuvette. There are different types: rectangular, square, circle shaped cuvettes are there, and made up of optical glass for visible wavelength, then coats or fused silica for UV, and optical path of cuvette is always 1 centimeter. And there will be a detector or a photosensitive detector. They are transducers which convert this particular light energy. Here the light energy absorption are in a light energy. This light energy is converted to an electrical energy. There are different types of detectors. Photocells are there. Then the last one is detector. The not detector, it is a readout device, that is digital, here digital display meter. The readout devices may be galvanometer, ammeter, or a recorder, or a digital readout. The signal may be transmitted to computer or printout.
Now we can look working of a colorimeter. This is a colorimeter present in our department. Here we use systolic photoelectric colorimeter. It is 113 type digital photoelectric colorimeter with 8 filters. There are similar products from different companies are available. Looking at the surface of this instrument, first you can see a display. This is a 3-digit digital display. Calibrated optical density measurements are seen here. Next, you can see filters or monograms. There are 8 filters are available to this particular colorimeter. You can see 430, 470, 490, 520, 550, 580, 610 and 700. Light from the light source hit in this particular filter and only allowed to the pass specific filter. Here we choose a 490 nanometer filter. So this particular chosen filter, light only pass through the exit towards the sample solution. Here will be the sample is placed here, the sample holder or cuvette. There are different types of cuvettes or shaped cuvettes are available, rectangular, circular. Here a circular cuvette is used. It is made up of silica Brussels cuvette. The cuvette should be transparent, clean, devoid of any scratches. Next, we can look an operating of the colorimeter. Here, we already displayed the operating procedure. Instrument should switch on before 5 minutes of operation. Here, we already switch on and choose the appropriate filter, that is 490 nanometer. Next, we can look to the samples to be measured. Here, we are going to measure concentration of sugar using phenol sulfuric acid method. Standard is prepared using phenol sulfuric acid. You can see this standard is always from a lower concentration to a higher concentration. From this, the OD of standard will be get. So the concentration as well as optical density is obtained from it through formula as well as graphical methods. We can calculate the test concentration by measuring its optical density. So here I am going to demonstrate one measurement for a blank. First we take a cuvette, clean transparent cuvette, and clean it before placed in set the OD as 0. This is a set is as 0. Next, I am going to measure the first standard. Placed here. And measure the optical density. Like that, all the standard solution as well as test should be measured. And from these measurements, through calculations and formula, test sample concentration can be found out. This is all about the calorimeter and its procedure. I think all of you understand or clear about this topic. If you have any doubts, comment on chat box. I will clarify to you. Thank you.